Hello, everyone, and welcome to another episode of the MRMIA broadcast. I'm your host, Mark LaPrince, and this is another episode of the Model Risk Managers International Association broadcast. Today, we're joined back again with John Hill, an adjunct professor at NYU Tandon, and he's going to discuss with us another longer form presentation. So just as like last time when he presented to us the history of model risk, today he's going to touch on smart models. So John, why don't you give a short introduction to those that haven't seen your previous video?
Okay, my name is John Hill. I have over 20 years of experience working in various areas of model risk management, including validation and governance at three major global investment banks. But currently, I have an appointment as an adjunct professor of model risk, and I believe I am the first ever professor of model risk at any university. Never been able to locate another one, and I teach a class in model risk governance and model risk management at NYU Tandon. And one of the things I discovered very quickly is that graduate students there in quantitative finance know a great deal about econometrics, about options theory, about stochastic mathematics, risk, but virtually nothing about model risk. It doesn't seem to get treated in any of the classes that they teach. So that was the reason the head of the department, Peter Carr, recruited me to offer a class in model risk management, because Peter knew me from my days at Morgan Stanley when we both worked there, and I gave a few presentations for his seminar series. So this presentation I'm about to give today has been growing continually. Every year I add a couple of more items to it, but this presentation is one that I give in that class. The presentation I gave previously was the history of model risk, which is my introductory presentation. This is one of my more advanced presentations when I tell the students about some of the forward-looking ideas that are now prevalent and being considered in this field of model risk management, which I think it's growing very, very aggressively in different directions. You hear a lot about machine learning, a lot about applying artificial intelligence to the process of model risk management. But I'm going to be talking about smart models in a very different way today. The title of my presentation for today is "A Smarter Model Risk Management Discipline Will Follow from Building Smarter Models." And as I'm going to explain, by smarter models, I'm not referring to the incorporation of artificial intelligence and machine learning into models, though that's also a valid description. Those models are smarter too. But I will call this an abbreviated guide for building a new generation of smart models. In this presentation, I'll make it very clear what I mean by smart model. So again, my title is Adjunct Professor of Financial Risk Engineering. I specialize in model risk, teaching model risk management to graduate students at NYU Tandon. I've worked for a number of years in model risk management at major investment banks, and currently as spending my time teaching the next generation about model risk management. So I want to start exactly by describing what I mean by this meme smart model. And I'll say in full disclosure in advance, so that this concept is shamelessly borrowed from tech companies and based on the concept of smart devices that they've been producing for many different years. We all talk about smartphones, smart printers, smart cars, and I mean smart models in the same sense that tech companies talk about their smart devices. So it's not employed to characterize the application of AI ML techniques to quantitative modeling. That's a valid application too. In contrast, I use the phrase smart model as a meme to describe quantitative software that possesses a rudimentary form of self-awareness. And that's the critical difference. To put it in more prosaic language, by smart models, I mean models that know who they are. And as I've said earlier, this concept is inspired by the proliferation of smart devices in self-driving cars, smart printers by tech companies. precisely how the types of quantitative models used in finance can be made to know who they are and the ways in which model self-knowledge might be applied to their management will be the focus of this presentation. I really began by asking myself, if tech firms can track the how, when, and where of their millions of devices are being used every day, shouldn't it be possible for firms to do the same thing for a few thousand quantitative finance models? But let's first, I'll start with a review. For those of you who may not be familiar, I'll briefly go through a review of what a model is and what model risk management is all about. The Bible for model risk management at conforming banks in both the US and most European banks is a document called SR 117/OCC 2011-12, jointly issued by the FRB and the OCC. And it was a 21-page document that set the bar in 2011 for model risk management at all conforming banks. I'm just going to pick a few quotes from this document. One, SR 11.7 provides the working definition of a financial model. It's a quantitative method, system, or approach that applies statistical, economic, financial, or mathematical theories, techniques, and assumptions to process and to put data into quantitative estimates. A model consists of three components: input, which delivers assumptions and data to the model; a processing component, the calculating part, which transforms those inputs into estimates; and a reporting component, which produces an output. I have an asterisk at the bottom for a quote that I think is very relevant to introduce at this point. Because all models are based on assumptions and not first principles or laws of nature, all models in finance are wrong at some threshold of accuracy. This brings in George Box's famous 1987 quote that captures this statement: all models are wrong. The important question is, how wrong can a model be before it stops being useful? That's true about models in many different areas of science, but it's especially true in finance. So all financial models employ approximations based on assumptions. And because of that, model risk can never be completely eliminated, but it can be mitigated to some extent. So these are the 5 takeaways from SR 11.7 that I think are important for model risk management. The purpose of model validation is determined not if the model is right, but whether or not it is useful for the intended application. Model governance differs from model validation in the sense that it also addresses the risks outside and between quantitative models within a firm's entire model ecosystem. Governance impacts every phase of a model's life cycle, and validation is one central phase of that life cycle. Critical, but it's only one part of it. Governance is an umbrella over all aspects of the model life cycle. A robust model governance framework will provide complete coverage for policies, procedures, roles, and responsibilities, model validation, ongoing monitoring, documentation, and model inventory. This is a topic that tends to get overlooked in many presentations, but it's one I'm going to focus on in this presentation. The biggest challenge for model inventory is ensuring accuracy and completeness. That's a requirement of SR 11.7. But at almost all firms that I'm familiar with, this is performed through a manual attestation process. So this is the life cycle, typical life cycle of a financial model. Starting on the left hand side with identification and initiation, then development and testing, that's first line of defense. Independent validation and approval, that's the second line of defense. It's right in the middle of that life cycle. In a well-run organization, new models cannot go into production without going through an independent validation process. Following validation, there's implementation into production and entry into the inventory. Then during the life of that model, as long as it's used, maintenance, change management, and ongoing monitoring. And finally, models eventually get retired. Almost all models have a lifespan. They become obsolete, or the data is no longer available, or for various reasons, they end up being retired. Now, a well-designed and enforced model governance will create a control framework that covers every one of these phases of a financial model's life cycle. Now, I'm going to list here what I consider to be 5 of the most daunting challenges facing today's model risk managers that involve inventory. 11.7 requires banks to create and maintain an accurate and complete inventory of all models. That itself is a real challenge. It probably won't surprise many people listening to this presentation if you've worked in the banking industry that most firms actually do not know how many models are in use throughout their firm. But SRS 11 also requires, 11.7 requires banks to be able to aggregate um, model risk across the firm. And in order to do that, it's critical to understand model and data interdependencies within that firm's model ecosystem. And this can be especially problematic because mapping dependencies also relies on multiple levels of attestation. It's impossible really to aggregate model risk up to a high level that's required by SR 11.7, which asks for model risk at the firm-wide level without taking into account all the interdependencies between models rather than treating them as individual standalone objects. Virtually every financial firm tries to satisfy these requirements through verbal attestations. That means voluntary declarations by model owners and stakeholders, which are developers, supervisors, and users. In other words, they have to raise their hand and attest that they have a model, and this is a model that should be validated and submitted into inventory. Because attestation is a manual and error-prone process, it is questionable if any firm can truthfully claim to have a complete and accurate model inventory, much less a complete map of model and data interdependencies, because data interdependencies can have multiple levels, so that requires multiple levels of accurate attestation. So to illustrate the central dilemma of model inventory, I'm going to present now what I consider to be the 8 most vexing questions that model bank examiners and regulators might pose to a model risk manager about inventory. And I produced these questions because before a bank exam a few years ago that I was going to be involved in, I took an hour to sit down and write the questions that I was most afraid of being presented with during the coming bank exam on the way models were being managed. And what I noticed when I finished writing down these questions that none of them had to do with validation, because validation is a pretty mature process. Most firms have been doing this for 10 or 15 years or more, and it's very well established set of procedures to validate models. But inventory has been more of a blank slate in the way it's been treated at firms. And so have these examples of questions that really troubled me. What is the exact number of different models that have been used by your firm over the last year? Second question, how often has each model been executed, day, by month, by year? And can you identify the most frequently used and the least frequently executed models? Where are the firm's models being used? By business, by department, by legal entity, and geographic entity. Who's using the models and where? Can you provide a complete list of the models used by each of the above entities over the last year, as well as all upstream and downstream model and data dependencies? Question number 5, are there any models in your inventory with an active status that were not executed during the last year? Now, this one is really kind of a fascinating question, because I imagine any inventory manager would just pull his hair and say, if the model was not executed, how would I know that? Well, I'm actually going to show how that question could be answered. And why is it an important question? Well, a firm invests a great deal of money in developing models. If a model has been developed, put into inventory, and doesn't get used, that's something that should be examined. It may be that the target entities that were supposed to use that model are not using the correct model, perhaps, or it could have fallen through the cracks. There are any number of reasons, but if there's a model with active status that doesn't get executed over a period of year, it's certainly something that should be accounted for. Number 6, are there any models that were not executed on any of your, that were executed on any of your firm's computers that do not appear in inventory? Please provide a full listing. Again, if it's not in inventory, how would we know? 7, are you able to provide a full list of the IDs, that's the identification number, of models that exhibit significant seasonality? If so, what are the peak and troughs of seasonal model usage? And lastly, were there any instances of a retired model still being executed during the last year? The model's been retired, and yet it's being executed. There may be legitimate reasons for that. Could be a research group, could be used as a benchmark, but if it's been retired and is still being used, that is something that model risk management should be aware of. Now, it shouldn't be so difficult for top tier financial firms to give accurate answers, and I mean quantitative answers based on data, to these types of questions about model usage. But most firms can only answer this is through attestation by model owners and users. Um, when in my situation at every firm I work for, the only way I could answer those kinds of questions would be by calling up the model stakeholders of the model owners and asking them, how often is your model being used? And typically I would, unless it was a daily model like daily VAR, I would get answers like, well, we don't really know who all the users are, but we think maybe it's once a week. And that's usually the best kind of answer I would get, a sort of guesstimate. But the only way most firms can answer this is through attestation. And that's no better than informed guesswork. It may be accurate in some cases, but in other cases, it may be very vague. As a result, there are often discrepancies between what is in inventory and what model owners have attested to. You can imagine being in a bank exam, and a bank examiner goes through inventory, the model inventory, picks one model at random and says, who's using this model and how often was it used over the last year? And this happens, say, to be a model used halfway around the world that was developed for Singapore. I would have to say, I'll have to get back to you tomorrow. And the bank examiner say, why do you have to wait till tomorrow? And I say, because everybody's asleep over there. And I have to call up the model risk managers in Singapore and ask them this question, because there is no resource I could go to, no database that would have this kind of information about the dynamics of model usage in it. So my question, the question I asked myself, and the reason motivated me to pursue this line of research, is the belief that there should be a better way to ensure inventory completeness and accuracy than model attestation by model stakeholders. Again, this was inspired by what I saw with the tech companies, that they can track usage of their devices, and perhaps millions of them at a time. And it was a real problem, and the financial industry to track model usage for even a few thousand models in inventory. Resolving model ownership discrepancies can require many numerous iterations of the manual attestation process to determine the current correct ownership. I personally had this experience many times when I would send a list of models to the stakeholders, the owners, based on the information that was in inventory. I would send them, say, a list of 15 or 20 models during the annual attestation, say, are these your models? Do you agree that you own them? And sometimes they would get back an answer that said, yeah, 14 of those models are ours, but I don't recognize those other two. I have no idea who owns them. And there would be many iterations of this, and eventually I would discover these models were orphans, meaning that the owners, the developers of the model, had either left the firm or moved on, had not bothered to annotate anything in the inventory to indicate that change. So we would have these dangling models that didn't have ownership at all. And add to that problem are the upstream and downstream dependencies between models. Downstream dependency, of course, are the models, downstream models that use output from the model at issue, and the upstream are the models that provide input. Model owners often do not have complete knowledge of all of the downstream models that receive their models output. And the reason for that, again, is very often these models will be in analytic libraries, and they can be checked out with used by anyone who has permission to access them. And the model owners generally are not informed of that. They would tell me, well, we know about the owners who call us up and ask us about our models, the users, but we don't really have complete knowledge of who all the users of our models are. And when it came to upstream dependencies, that's something that model owners and developers certainly should be able to understand. They can trace inputs. All inputs to their model should be traceable, and they can trace it back to a market resource or back to another model. But in my experience, I found that owners of a model would trace upstream dependencies to the very first level if they reached another model that was upstream to their model, and that's where they would stop. And the reason they would stop there is because they didn't own that upstream model, and they never typically pursued the question, does that upstream model have additional levels of upstream dependency? And that's why I found typically the upstream maps were often incomplete, because there could be multiple levels of upstream dependency that were not detected by the model owners. So my feeling is in the age of automation, machine learning, and big data, we should really ask ourselves if we can't find better ways to make firm-wide model and data usage more transparent. And these are questions that do come up in bank exams. They're just not idle speculations. Because I've said some answers may be found by going to the source and engaging an articulate model in a candid conversation. Comes to my favorite part of this presentation. As I said, manual attestation can be both clumsy and error prone, and some models may be overlooked because they're orphans that have fallen through the cracks. But just imagine if a model could only talk, perhaps the model itself could give us some advice about how to better understand how, when, and where these models are being used. So I'm going to have now put up an imaginary conversation with a slightly snarky model that might go something like this. So this is MRM on the left, the model risk manager, saying, hey, model, let's have a little talk. And the model says, oh, sure, but you may regret this later. And MRM says, why so? Some of my best friends are models. And the model says, because you MRM guys are not really the sharpest crayons in the box, are you? Now, you're still living back in the Stone Ages. And the model risk manager says, well, that's a zinger. Why would you say that? And the model might say, well, MRM spends so much time and effort collecting inaccurate, error-prone manual attestations from model owners and users just to inventory which models are being used. It's such a 20th century process. But the model goes on to say, you could make your life so much easier if you would just reverse the manual paradigm. It's simpler, more accurate, and quite frankly, kind of obvious. MRM says, but tell me, my friend, how can MRM possibly reverse a paradigm that's been in place for years? Model says the solution is all around you. It's in every smart device that you use every day, and printers, computers, cars, smartphones, email, data networks. All you have to do is look. MRM says, I still don't get quite what you're driving at. And the model says, okay, listen carefully, dingbat. These devices all know who they are because they have unique IDs and a means of broadcasting, which I don't have. If you would just give me an embedded identity token and a voice, then I could tell you how, when, and where I'm being used. It's pretty obvious. Model risk manager says, now I think I'm getting it. All I have to do is teach you your name and how to talk. Is that right? It's an epiphany, but exactly how would I go about doing that? And the model says, well, just follow the rest of the presentation. Maybe it'll start to sink in. So here is my conclusion that I drew in facing these dilemmas of answering questions about model usage. The root cause of these difficulties is not hard to find. Our models, no matter how sophisticated their algorithms and implementations are nevertheless really rather dumb when compared to an HP printer or an iPhone. A smart model should be able to report who it is, how, when, and where it is being used, and which upstream models it depends on. So we only need to make models just smart enough to perform these simple operations of reporting their usage with a unique identity token. By the way, this is a technique that's been used in email and computer networks for at least 3 or 4 decades. Nothing really new about this idea, except it hasn't penetrated into finance, except in a few very limited cases. Designed correctly, smart models could eliminate the need for a manual attestation process. So there are plenty of examples in technology that said a smartphone knows its unique serial number because it's embedded in the permanent onboard memory, the firmware that's with the firm for life. Uber ride service is a good example. They track the current geographic location of every one of its active vehicles and advises clients on location and estimated time of arrival. Tesla has the ability to track every one of their vehicles and service at a given time for many different parameters: location, travel, speed, level. They may have a global map somewhere in their headquarters so they can show every single car that they've made and where it is and how fast it's going. At Hewlett Packard, I have a Hewlett Packard smart printer. Every time I make a printout, that printer sends a message to Hewlett Packard, giving the IP address, which can be mapped to my physical address, and telling Hewlett Packard what my current ink level is and how many pages I've printed, so that they can send me a new cartridge before I run out. So I don't have to remember to do it or remember even what type of cartridge I should have to order. So what is it that smart devices like printers, iPhones, and Tesla vehicles have that financial models do not? To understand what is missing from financial models that makes them kind of dumb, in my point of view, we only have to dig a little bit deeper. Just look inside the source code for any complex financial model and see what you will find, regardless of what language it's written in. You're probably going to, if it's a complex, well-written model, it'll have very sophisticated algorithms, highly efficient, optimized code, very likely to use the latest concept in object-oriented design, and perhaps be coded for efficient dynamic memory management. But what you won't find, as a general rule, are some very simple lines of code that look something like this. Model ID equal, model version equal, model usage ID equal, and the model name. Now, this is very simple information that can be embedded in the actual source code for the model and executed just at the beginning, whenever the model is called, these declarations are made. So the model literally knows its own ID, knows its version number, knows its usage ID, how this model is being applied, and its name. A lot of other information can be added to this. This is just an example. I've looked at lots of model source code. I never encountered anything that looked anything like this. Software implementations that are classified models, you have unique IDs. This is a standard practice now throughout the industry. It wasn't always. At most, I can mention that a little bit later when I talk about the history. At most firms, these model IDs will appear in three places: in the model documentation, in the validation documents, and in the inventory database. As in a previous slide, where they do not appear is within the actual model source code. It's in this sense that I claim that models do not really know who they are, because that identifying information is held external to the model. So it doesn't travel with the model, it's only maintained by monitoring systems. The root cause of model usage opacity can then be traced to this single surprising blind spot in most firms' model management discipline. Adding this one piece of information, identity token, with that identifying information to a model can create a path to mitigating or even eliminating model inventory and usage uncertainties. It's a matter of creating smart models that are enabled to tell MRM how, when, and where they're being used. Model IDs are relatively new in finance, but certainly in manufacturing, they're equivalent to serial numbers. Manufacturing, of course, has used serial numbers for centuries. And most smart electronic devices today have the identifying serial number embedded in onboard firmware. This idea simply has not found its way into finance as a general practice, because models were developed long, long before we ever started assigning unique model IDs to our models. That occurred mainly when firms recognized the need to store all this model information, the documentation, the validation information in online databases like a SQL database. And at that point, unique IDs became mandatory to serve as an index into the database. And it's that period, which usually probably occurred in the first decade of this century, that the firms started comprehensively assigning model IDs and using those as an index into their inventory. But apparently it wasn't obvious, and it wasn't a practice to actually put that model ID inside the source code of the model. So the crux of the matter is this, and this is part of the reason why this did not become a practice. In financial firms, model developers and model risk managers work in separate silos. Model risk managers are tasked with identifying and mitigating the holistic model risks that reside throughout the model ecosystem, whereas model developers are tasked with designing and implementing testing models that efficiently convert input data into useful outputs. These two groups work completely independently within most financial firms. Also, in most firms are managed and executed, and a number of most models in most firms are executed in a number of often incompatible execution platforms. So one consequence of the silo mentality is that model developers tend to have little interest or motivation for modifying their models to accommodate the requirements of MRM. In fact, anyone familiar with the situation in most financial firms. There's a natural almost tension between model owners and model risk managers, because model risk managers have oversight and they review and have the authority to fail models. So it's not always a friendly relationship between first and second line of defense. And so I can understand, if at first line of defense point of view, that why should they do anything to make the job of the model risk managers any easier, although it is actually for the benefit for the firm. But if they did work together, some simple changes could be made by developers to a firm's models that would greatly improve the MRM discipline. And three of them are: one, create identity tokens composed of that unique indicative data, as I showed in the previous slide. Embed those next, embed active intelligent agents to accurately track model usage and support creation of a dynamic inventory model. This is something new I've just introduced in this slide, the active intelligent agent. You can think of it as a transponder or a broadcasting function that will be executed each time the model itself is executed. This a third way that MRM and model developers could improve the whole process by working together would be to create a methodology to exchange identity tokens between interdependent models and data, supplies of data just as well, to create a dynamic map of model and data dependencies. A dynamic map, I'll describe in more detail in a few slides, but no financial firm appears to do this today. I say that with complete conviction. I think no firm today relies on passing identity tokens from upstream to downstream objects, although this is commonly used in email, for instance. So let me just, some people have had trouble understanding exactly what I mean by passing identity tokens from upstream to downstream entities. So it's easy to understand by making an analogy to a four-person relay race. I'm sure everybody who's watched track and field is familiar with these four-person relay races in which a single runner starts with a baton, runs part of the way around a track, and he hands off the baton to a second runner, who then does another section of the track and hands the baton off again. So I'm going to modify this, make one simple modification. In this analogy, each runner will have their own baton of a different color. So starting at the top, runner number one gets set. He's carrying a red baton and he starts running down the track. When he's finished his part of the track, he encounters runner number two, who has a green baton. And now that runner number two starts down the track with not one, but two batons, a red and a green baton. Runner number three then encounters runner number two, encounters runner number three, who ends up with three batons, red, green, and blue. So runner number three does the final, third link of the track and encounters runner number four, who has a yellow baton. Runner number four now will have four batons, and he will complete the race with those four batons: yellow, green, blue, and red. This is an exact analogy to what I mean by passing identity tokens from upstream to downstream. By the time you get to the end of the process, you have tokens that identify all the upstream contributors, in this case, the other three runners. And finish. So what kind of usage data might an embedded active intelligent agent send to model risk managers? So this idea is really inspired by transponders that are used for aviation to track civilian aircraft. A transponder, or you call it a tracking function, can act as an intelligent agent embedded in the model that will be called once each time a model is executed. And at a minimum, it would broadcast the following fields in some way to a centralized model usage repository for each execution event. And that would be the model usage and the usage ID, because models may have many different applications, and typically each application will have its own usage ID. The model name and version number, that's critical information. The timestamp, this records when that model execution event occurred. I listed here as month, day, hour, and minute. That granularity may not be necessary, but that's something that's obviously going to be determined by usage. And then a MAC or IP address. What is a MAC? That's a media access control, and it's the hardware equivalent of an IP address. So the MAC address is embedded for every processor, every computer, every laptop has its own unique MAC address, and that can be read by a call to the operating system, which is a unique identifier of that particular laptop and therefore the processor that's being involved in the execution. And every firm that has firm-owned computers should have a list of all the MAC addresses for every device that they own and the location and whoever that MAC address is assigned to. IP address is equivalent. That's the internet equivalent that identifies an entity uniquely. My Hewlett Packard printer, for instance, has an IP address which uniquely identifies it. Now, if these data are stored for every execution event, for each model in inventory that is assigned a unique ID, there would be a treasure trove of model usage data that will accumulate over time. It's the second step towards creation of what I call a smarter model. Models equipped with an embedded intelligent agent that can automate usage tracking. The data can form the basis for a dynamic model inventory. And I emphasize the word dynamic here because all model inventories that I'm familiar with used in finance are static. They have a lot of important static information, but they don't carry dynamic model usage information that can answer those 8 questions that I presented earlier that I think are very vexing for model risk managers. So this dynamic inventory would include continuously updated information about how, when, and where models are being used. Passing tokens from upstream to downstream entities can form the basis for a dynamic map of model and data interdependencies. I mentioned earlier that this is not a new idea. So let me just mention briefly about how it's used in email. If you've ever wondered why email is not instantaneous, the way, say, a phone call is when you're talking to someone, it's because email does not go across a voice network. It goes across something called a data packet network. This goes back a long way. Originally developed by DARPA for military usage. Packet data networks can be very efficient because they have optimizers that will balance loads across all the links. So when you send a long email out, when you hit that send button, the local server actually breaks that message up into individual packets, data packets. I think they're typically 128 characters. Each of those packets is assigned an identity token, which identifies what sequence the packet occurred in the message and the parent of the message. These packets now can all be treated independently so that they can travel by different routes through the packet data network. So you can have 2 packets from the same message that go on remarkably different paths through the packet data network and travel remarkably different distances, but only when all the packets have arrived at the destination and have been reassembled in the correct order, you get that message that tells you got email. That's why email is not instantaneous, but you can see very easily that this allows model risk management software or network management software to optimize the efficiency of the network by load balancing, making sure that no particular link becomes overwhelmed. And the drawback to voice networks, as everyone knows, in times of a crisis or a major storm or terrorist attack, the voice networks become completely jammed. Packet data networks can avoid this by parsing out loads uniformly across the entire network. So that's why I say this is not a new idea. It's been used for a long time. Computer networks use token passing as well. So conceptually, this model usage tracking is pretty simple. The most important goal is to achieve independence from an execution platform because that will make it both scalable and mobile and portable. So starting on the left, any model with an ID, when it's executed, the transponder function will send out model usage indicative data and an identity token. This can go via the intranet into a centralized database, intranet, not internet, the internal intranet for a firm, or it could be put into a temporary local file. And this model usage indicative data information then ends up in a cumulative dynamic model inventory database. Now, this is a simplified version. Implementation is going to have a lot of details that will require working out. But for me, the proof of this concept using simulation is one of the best ways to demonstrate the potential of this idea. This can be implemented without impacting production models by leveraging a portfolio of synthetic or dummy models consisting only of embedded IDs and a transponder function, just to show what kind of information could be collected. So the graphs displayed in this following were produced collecting 4 data fields for each of 100,000 synthetic model execution events. 100,000 execution events over 100 synthetic models, each one of which was equipped with an embedded identity token and a prototype transponder function. And I'll actually show you the source code for that transponder function in a few slides. The simulation horizon here was over 3.5 years. So model ID, model name, timestamp, and MAC and IP address are the only usage data required to produce the following types of graphs. Timeline plots of usage for any group, model, or grouping of models, a histogram distribution of model execution frequencies, and a global map showing concentration of model usage with sufficient history. The global map can be animated to produce changing usage patterns through time. That's something I don't think any firm can do today. Here's an example of a simulation dashboard, the kind of information that can be collected with the simple modifications, the innovations into the source code of a model I've described. At the top, you see a line graph showing frequency of model usage through time. This is for a particular model. On the lower right-hand side, you see a histogram of model usage, which very quickly tells you where to look for the most frequently executed models and where to look for those that are not executed at all. And in the lower left, you see a global representation of where these models are being used. That's what the IP and MAC addresses are useful for. This dashboard was created as part of a simulation that was produced by a consulting firm called FI Consulting in Virginia. David Leonard actually did this work in collaboration with myself after he saw my paper. And as I said, the graphical dashboard was implemented on an Amazon web services cloud platform. So here's the actual code that he developed for the transponder function. And my only point here is not to dwell on the code, but to show that it's pretty simple, just 12 or 13 lines of our code. And this transponder function, by the way, should be in a central library, and the model itself would only have a call to the function, but not the source code for the transponder itself. So now at this point, I think I'm ready to go to a video demonstration of what I've been talking about. Let's see if I can pull this up. So this is the voice of David Leonard. As a model risk
manager, you know the number of your models is increasing, but so are the number of questions from your auditors. That's why we, in collaboration with John Hill, created the Transponder tool, a simple yet powerful software system designed to make your life easier. The Transponder tool is comprised of 2 main components: a dashboard that lets you easily see all of your model run history and metadata, as well as a easily embeddable function that powers the entire system. Now, as you can see on the screen, the dashboard shows model run counts by date, location, and user. Likewise, each of these fields can be filtered by things like model name, model type, model language, and more. So if, for instance, auditors ask you for more information about your commodities models, you can quickly tell them when, where, and by whom those commodities models were being run. What's also helpful about the Transponder tool is it captures and stores each model run and its corresponding metadata in an easily viewable and filterable log, like the one on the screen. Now, this log is actually populated every single time a model connected to your system runs. How is a model connected to your system? Well, that's the cool part. It's as easy as the 2 sections of code you see on the screen. The top function sits in a shared repository and contains the functionality used to send metadata to your system's dashboard. The bottom line of code simply gets embedded in the heads of each of your models, and then every time those models are run, it calls the function that we just talked about. So let's see an example in action. Imagine that this postlog function was embedded in our model. When we highlight it and click run, we'll see in the console that the postlog function was executed. Now, when we navigate back to our dashboard and we come up here and click refresh, we'll see that our entries actually go from 100,000 to 100,001, with the latest entry being the one that the postlog function just created. One final cool feature of the transponder tool is that it lets you examine modeling behavior over time. So if, say, an auditor asked you where your models were being executed, you could set a date range, hit run, and provide the auditors with an interactive visualization that answers their questions through a historical lens. So that's it. That's the transponder tool. It's simple, but extremely powerful towards the end of providing you with unprecedented insight into your modeling processes. If you'd like to learn more about our transponder tool, or if you're just interested in learning how to develop your own, let us know and we'll be in touch.
Okay, so that video probably tells you a lot more about what could be done with these simple innovations and all of my slides put together. There's nothing like a dynamic presentation. And particularly that last part where you saw a global map that showed changing patterns of usage through time. That is something I'm 100% certain no firm can produce today, no financial firm, and based on actual execution data. Only through attestation data would be able to do something like that. But it could produce a lot of information that's not readily apparent to humans by examining these execution logs, like patterns of behavior that change with seasonality. So whenever there's a large amount of data, data mining experts almost invariably will find correlations and relationships that weren't observable on human review. So I'm very optimistic that if this kind of dynamic data is actually collected, there will be some very interesting discoveries about the how, when, and where of model usage. So now I'm just going to finish up by summing up what I consider to be the advantages and the disadvantages of this approach to tracking model usage. First advantage is the solution is inside the model. That's a critical difference because there are execution platforms that can track this collect this kind of usage data, but they are always external to the model. And there's no firm today that runs all of its models in a single execution platform that I know of. At the firms I've worked at, we had dozens or even more than 50 different execution platforms. The model transformer approach places the tracking software inside each model rather than relying on this external platform. And it will work equally well, therefore, for the large IT-controlled or small standalone EUC models. That last comment is very critical because EUC models typically are not run from any sort of IT-controlled execution platform. And these are just the models that don't tend to show up reliably in inventory and are not well accounted for because they're so easy to create, and very often they're not submitted for validation into inventory. The second advantage is this is a readily scalable solution. If it works for 10 models, it will work for 10,000. It can be scaled and it can be done piecemeal, starting with a small subset of models and growing the penetration of this approach through time. It doesn't have to be done all at once across the firm. It's a comprehensive solution because it's platform independent. Again, I have to emphasize the advantage of platform independence. It's a global solution that would operate on any firm computer that has access to the firm's intranet or can just write results to a temporary file. The proposed innovation can be implemented incrementally over time with limited sets of models. As I said, it doesn't have to be done all at once across the entire firm. Even if it's done for, say, the CCAR models or one set of PPNR models, the information collected could be very useful. Lastly, this can dynamically trace model and data interdependencies. It offers a direct token-based means for comprehensively identifying upstream and downstream dependencies based on execution processes rather than attestation. And if a little bit of thought, one should realize that this kind of data will be dynamically updated whenever a new model is introduced in the ecosystem. It will automatically be included in this dynamic database as long as it participates in the token passing process. Same for any models that are retired and removed from production, they will disappear from this dynamic database. So solutions that depend on, say, comprehensive searches through source files to determine dependencies, which is one approach that some firms use, produce a static map that becomes stale with time. Disadvantages. It touches every model. It requires minor additions to the source code of each model to be tracked. And although it won't affect performance, there's always some inertia and resistance to modifying models. It's possible that a high bandwidth from heavily used models could bottleneck the firm's intranet, but there's certainly ways of filtering that and only transmitting the important information. Vendor models will represent a special challenge because it's doubtful that vendors are going to agree to install identity tokens and transponders in their models, but there probably are workarounds because most vendor models are called not directly, but through an in-house execution script or host program that firms use to interface to the vendor code, and that's where this transponder and identity token could be embedded. EUC spreadsheet models. These can present challenges as well, but they're not insurmountable. If the spreadsheets incorporate model code, such as VBA or link libraries, then the transponder tracking function can be embedded within the code or link library. Lastly, I think this is probably the biggest disadvantage. Most large established financial firms tend to be resistant to change, and especially this kind of innovation. Pushback from IT organizations should be expected. I actually did present these ideas to one firm, and it was interesting that the quants involved, the second line of defense and first line of defense quants, were pretty excited about this idea, but the IT staff were horrified because they basically said, look, we've spent years building firewalls around our models to protect our precious proprietary information, and you want to drill holes through those firewalls with your intranet communication. And my first remark was, well, it's your intranet. If that's not secure, you've got bigger problems than this. But there is a workaround. You could still put the results into a local database inside the firewall and just collect data, say once a week, do a sweep through all the local databases into a centralized database. That adds an extra level, but it breaks any direct connection between the model and intranet. So let me just sum it all now. In a nutshell, embedding identity tokens and intelligent agents into models can reverse the manual attestation paradigm. What I'm saying is model attestations are just being performed backwards. MRM relies on model owners and users to testify to the complete set of models that they use through a manual error-prone attestation process. It's just easier and more accurate to enable models with intelligent agents that can inform MRM about how, when, and where they're being used. Reverse the paradigm, and smart models can then do a lot of the work for MRM and unload a lot of the manual overhead that's involved here. This single innovation could replace our 20th century manual attestation process. But however it's done, the most important takeaway from this presentation is that any usage tracking solution should reside inside the model code. Only in this way will it be both portable and fully scalable across all execution platforms and implementations. So I'm going to show you a couple of slides now that were kindly provided to me by David Asermley, who's head of model risk management development at SAS Institute. His team is developing a prototype based on these ideas. He heard a presentation I gave about a year ago and felt that it was a solution that he'd been looking for several years for tracking model usage data. So he uses this token, this baton passing analogy to explain what we mean by token passing. And SAS Institute has created a prototype test platform within their test bed within their MRM platform using embedded identity tokens that are embedded in all model results. Identity tokens are then passed from upstream models and their data to downstream recipients. We used to create a dynamic map of interdependencies. That's this map in the lower left-hand corner that is provided with the SAS platform. And this is updated whenever a firm's models are executed through the SAS platform. And model usage data is auto-generated. It eliminates the need for manual updates by model stakeholders. And David explained to me that's why their model usage module was the one module that didn't get used by any of their clients because it required stakeholders to manually provide that usage data. With this approach, this gets generated automatically. This prototype version is now available for testing by select SAS clients. This is a a slide that David used to explain on the left the different types of information, model usage data, accounting and finance and decision making from different families of models can whisper into the MRM ear there, and that then goes into the model risk management database and can produce that kind of complex network you see on the right. So regardless of how this information is collected, a complete map of upstream and downstream data interdependencies can be quite complex. And I and others recommend using a graphical network diagram, such as the example you see on the left, using synthetic data, is a very useful way of capturing these complexities. I use a tool called GPHI or GEPHI, GEPHI. It's an open source tool that's available, no licensing fee, and it does a fantastic job of taking interdependencies between entities and plotting them in ways that are very useful. In this case, each node here represents a model, and each arrow represents an upstream or downstream dependency. And you notice that the models with the highest number of interdependencies appear in the center of this formation. Those with the least appear on the outer rim of this galaxy type of representation. This can be zoomed and scanned across, so it can handle thousands of models and hundreds of thousands of interdependencies potentially. I've also published on everything you've seen here has been published in a paper. This is the title sheet from that paper in the Journal of Risk Management and Financial Institutions. That paper is available upon request to me by email. So I'm just going to quickly go through some recent publications. The one I just showed you, my first paper is called Shouldn't a Model Know Its Own ID? Where I just proposed the idea that model ID should be embedded in the source code, and it's going to solve a lot of problems if we did this. Second paper, I survey the field of the top challenges for today's model risk managers. And this last paper is what this presentation is based on, published in the Journal of Risk Management and Financial Institutions. I can provide copies of these papers to anyone who's interested by using either of the email addresses you see below. So, questions, answers, and discussion. You have any questions, Mark?
Just a couple comments here, John. I mean, as always, this is just fascinating, and I'm always excited to hear kind of the new ways of thinking about the same problems, right? There's numerous banks that have been doing attestations the same way you just described, manually going around, calling up lines of business, first line, model owners, trying to get information based on how these models are used, how they're executed, when they're executed, and by whom. And, depending on the size of the organization, they don't always know the model users. They don't always know how often these are getting executed. And you're basically going off of what everyone's saying. And it's really a fresh idea, I think, to kind of flip the paradigm on its head, just like you said, and let the models speak for themselves. I think it's just a fantastic idea.
Yeah, some people have remarked to me after hearing this presentation that it's so obvious. Why haven't banks done this from the beginning? And the only answer I can come up with is I said model IDs were introduced long after models were being created. When I first started my career in working in validation back in the early part of this decade, we just put all the model validation documents and test results, everything into file folders on a shared file drive. That was it. The name of the folder was the name of the model. That's how we indexed it. And eventually regulators looked at that and said, this isn't really going to carry forward into the future very well. You really need to put it into a database. And that meant we had to have unique IDs. And that's when only then did we start assigning unique IDs to models. It just wasn't done in the past. We just used the model name, which is not guaranteed to be independent. So this is, it's an interesting idea to me as well, because we're surrounded by the solution in all our smart devices. Manufacturers of all these smart devices can track usage. Some people say they track too much of our usage. It's an invasion of privacy. But the point is they can do it for hundreds of thousands or even millions of devices. And we're struggling in financial firms to do it for just a few thousand. These kinds of answers, the how, when, and where, how models are being used, what I call the dynamic inventory problem. dynamic challenge. As you said, let's make an analogy. I mentioned my Hewlett Packard printer and how it sends out a message each time I use it. What if Hewlett Packard were using our current approach to track usage of their printers? So every month they would send out an email to each of their known owners of a printer and say, how many printouts did you make this month? And what's your current ink level? That's kind of the equivalent to the way we do trying to ascertain downstream dependencies. And obviously, you would get incomplete answers at best, and they would just be guesses.
Right.
And when I was working in these firms, the only way we could ascertain all the downstream users would be to send out emails to the entire universe of potential users, and with an email that says, what models are you using? And how often do you use them? And of course, we would get occasionally, hit and miss responses. We certainly wouldn't get complete information that way. So these were the real world problems that I was wrestling with as a model risk manager, and why I realized that the solution was all around us. We just had not incorporated it into financial applications. So that's really how these ideas evolved. There are a lot of other innovative ideas also that are starting to be discussed. One of the latest, we all know about AI and ML. And we hear a lot about that in conferences today, but on the horizon is the use of blockchain technologies for models.
Right.
It's pretty interesting thought process. I've been working with one of the thought leaders in this field, and he has this vision that one day financial firms can, he calls it Uberize their models. They can do what Uber does to any car owner who can become an Uber driver and make money off of that commodity. Firms invest a huge amount of money in their models, and by making them available through blockchain, they can be rented by other firms, kind of like the way that Bloomberg does today. When you use a Bloomberg model and you're using an exclusive link to Bloomberg, the idea here is they can be put up anonymously on a blockchain and validated anonymously by qualified validators. So I shouldn't say anonymously, because the identity of the validator would be necessary, but validation documentation can be provided, and access to those models can be on a pay per usage basis. So it's an interesting idea that firms could start recovering some of their money by hiring out their models through blockchain and doing it in a very secure way. So there's an interesting set of new ideas finally penetrating into the model risk management arena, and which I find very refreshing, because it's been pretty stagnant for the last 15 years.
Right. Yeah, this is a completely, this is a very refreshing perspective, kind of merging the new ideas from the technology industry and merging it back into these silos. Because I think just from what I've seen in the model risk industry, things are siloed, right? Understandably so, because MRM has to maintain independence from the first line. But to answer those deeper questions surrounding model risk managers have gotten closer and closer to what I'll just generically call the model execution platform, right? They're starting to track performance of models a lot more closely, the inputs and outputs of those models a lot more closely. And those have only been exacerbated by AI and machine learning models. And you compound that with, the cheap compute you get with cloud technology. Model risk managers are digging their way faster and faster towards that execution environment. And so I think something like this will be extremely, extremely valuable. And it's just a natural step to go toward in terms of tracking exactly the kind of inputs a model's getting, from what source, at what time, right? And then being able to track it all the way through with those associated interdependencies.
Yeah, and token passing would provide a very accurate way of keeping track of all those upstream and downstream dependencies at every level of the model. And when you get to the end of the process, you have a complete set of tokens. So you know where the data and what upstream models were involved, and that can be dynamically updated into a database as it happens. Yet no firm does it that way today, and yet it's used in computer networks and email. These are old techniques. This idea of passing tokens around.
Yeah,
it just hasn't found its way migrated into financial modeling.
Well, I hope it becomes reality very soon.
Well, I'm hoping, of course, that SAS has some success with this prototype that they're implementing, and they'll find clients who are interested in it, and word of mouth may also. Without mentioning any particular, there is one firm I know of, one leading investment bank that is also working on a prototype of this. They have an individual there whose thinking is very similar to mine, and they actually are developing a prototype, but I can't really talk about it now.
Okay. Okay. Wonderful. Well, John, thank you as always. Love this discussion. And I really hope we can see some of these smart models one day running in production.
Okay, so do I. Thank you, Mark, for having me. It's been a pleasure. Really enjoyable experience producing these videos for you.